So you want excellence in NCEA Maths. Well, this video is all about that. And in order to help us understand how to get excellence, I want to first take us back to why the government actually makes us do maths in the first place. Why do we spend 12 or 13 years doing this? Well, some people think it's because, the government wants to torture you, or that you need to learn the quadratic formula or basic trigonometry before you go into the workplace. And of course, that's not true, because not all jobs involve that kind of thing. But what all jobs do involve is problem solving. That's the exact kind of thing that the government or schools are trying to teach you by teaching you maths for that long. And so in order to get excellence in NCEA Maths, what you're going to need to do is take achieved level skills and then apply some kind of layer of problem solving or abstraction on top of them and apply that to an excellence level question. So how exactly do we do that? Well, let's get into it. So far we haven't been very specific about what problem solving means. Let's get a clear process down. The first step to problem solving for excellence questions is understanding the achieved skills really well. The second step is visualizing using diagrams. And then the final step is turning those diagrams and those visualizations into actual algebraic equations. So what we're going to be going over is those three steps at level 1, 2, and 3. You're welcome to watch all of them or just the one that's relevant to you. Let's get into level 1. So the skill we're going to be focusing on at level 1 is parabolas and knowing their various forms. So the first form is ax squared plus bx plus c. This one isn't particularly useful. The next form is a times x minus b squared plus c. And this is actually quite useful because it tells us the coordinates of the apex or vertex. So an apex is the top of a negative parabola and a vertex is the bottom of a positive parabola. And the vertex is the bottom of a positive parabola. So the apex or vertex is at the coordinates bc. That's why we call that equation quite useful. And the next form is a times x minus b, x minus c, where we have the x-intercepts at b and c. So now we kind of have a base understanding of what our achieved skill is. Let's try and understand this more graphically in Desmos. So our first formula here is ax squared plus bx plus c. And if we vary a, what we're going to find is that we kind of stretch the parabola, but it's not super coherent what we're actually doing. If we vary b, we're kind of shifting it in some weird way. And if we vary c, we're just putting it up and down. It's just the y-intercept. Let's move on to our next form. So ax minus b squared plus c. If we vary a, then very clearly we're stretching it and it's kind of a bit more coherent than it was before. If we vary b, then we're shifting it left and right, which is really useful. We're just changing that position of that, in this instance, the vertex. And if we vary c, we're just changing the height of the graph once again. And finally, if we have x minus b and x minus c, once again, a is just stretching the graph, making it either very slim or very wide. B is going to change the coordinate of one intercept. If you look at the left-hand side, we're kind of making it much more negative. And C is going to change the other x-intercept. We can vary it like that. So now we have an understanding graphically. Let's try and apply this to an NCEA question. So this is the 2021 Tables, Equations and Graphs paper, and here I've got an excellence question from question 2. So it's telling us that we can model this real life hole using a quadratic equation, and we need to figure out how wide Roger's hole is at the surface of the water. And so what our instincts should tell us is that we need to find the equation of this particular hole, because it's a parabola, and then apply that to the problem. So in order to find the equation, we're going to first need to write down some of the information that we have, right? Because it's not immediately clear from reading the question. You might want to pause it and have a read to see if you can figure out how we do this first. I'll give you a few seconds. All right, so let's see if we can solve this question. So the first piece of information that I think is really important is the greatest depth. So that's at 2.5 meters. All right, so that tells us that this point right here is 2.5 meters deep. And it says that this is at a horizontal distance of 5 meters from Roger. And Roger appears to be at x equals 0. We've got some kind of axis to help us. And so we might put a coordinate on this particular point. We're going to say that it is 5 and negative 2.5. And if you noticed, it's actually a vertex, which tells us that we need to use one particular equation from the set I just gave you before, and that one is a times x minus b squared plus c, because b and c are the x and y coordinates of the vertex respectively. So we have 2 out of 3 of our unknown variables. We need to find a. How are we going to do that? Well, NCEA has gifted us a point that's not the vertex in order for us to figure this out. So let's first write out the equation y equals ax minus b squared plus c. And we can put in this point p, which is at 2, negative 1.375. And the way I got that was taking the x value of 2 and then saying it's 1.375 meters below ground level. And so we set our y value to negative 1.375, and that equals a, which is what we're trying to find, times x. We replace x with 2, x minus, well, our b was going to be 5 because that's our vertex, plus minus 2.5. And we end up being able to solve for 9 over 8 equaling a times 3 squared, negative 3 squared rather. So that was just adding 2.5 to both sides. Do that in a calculator, we get 9 over 8 on the left-hand side. We get 9 over 8 equals negative 3 squared is positive 9, 9a. Make that slightly longer so you can see. And now we can say that 1 over 8 equals a by dividing both sides by 9. And so we have our equation overall, which is going to be y equals 1 over 8 times x minus 5 squared minus 2.5. So now we can begin trying to find what the surface of this water is. And the way we're going to do that is actually sub in a y value of negative 2 and see what x values suit that. You could imagine we're trying to put a line of y equals negative 2 through this graph and see where it intersects. And of course it's going to intersect at these 2 particular points. And so what we're going to do is we're going to set y equal to negative 2. All right, so where is this equation equal to negative 2 is what we're asking. That equals 1 over 8 times x minus 5 squared minus 2.5. We're going to add 2.5 to both sides to get a half equals an eighth x minus 5 squared. We're going to multiply both sides by 8 to get 4 equals x minus 5 squared. And then we're going to say that plus or minus root 4 equals x minus 5. We just square root both sides. And now we're going to go x equals 5 plus or minus 2, which equals either 3 or 7. And so now we know that the points of the surface of the water are at 3 and 7. And so what that allows us to do is understand how wide it is, because the distance between 3 and 7 is 7 minus 3, which equals 4. And then we'll put meters in there. And so now we know that the distance between those 2 points is 4 meters. So what we did there was take achieve level skills, right? Trying to manipulate parabolas and input them into a more contextual environment where we have this real life context of Roger's hole, and we used our understanding of the structure of parabolas and applied that to real life, and we problem solved. Let's move on to level 2. So if you remember correctly, our first step is to be really familiar with those achieved level skills. And so at level 2 algebra, you should be pretty familiar with this idea of the quadratic equation. And so basically, if we have an equation ax squared plus bx plus c equals 0, then we can find the solutions to that equation using a much more complicated equation. Hopefully you can remember it off by heart at some point. That is negative b plus or minus the square root of b squared minus 4ac divided by 2a. And so those b's and those c's and those a's correspond to that original equation of ax squared plus bx plus c equaling 0 this time. So you also should be familiar with this concept of the discriminant, which is, we denote as the triangle, which equals b squared minus 4ac. And what I wasn't taught so much was that this is actually the same b squared minus 4ac as what's in here. And understanding this is actually really critical to understanding what the discriminant is actually doing. So if we think about it, there are 3 cases which our discriminant can be. So either discriminant is positive, as in is more than 0, or it is equal to 0, or it is negative, as in less than 0. And so let's think about that first case where it's positive. So that would mean that what's inside the square root in our quadratic equation here, that is also going to be positive. And so we're going to take the square root of a positive number, that's going to be another positive number. We're going to add that and also subtract that from our negative b, right? And that's going to produce 2 answers. So that's often the reason why we have 2 answers, is because we add and subtract whatever's in that square root. Right? Or it's always the reason that we have 2 answers, in fact. If the discriminant is equal to 0 in that second case, then we're going to take the square root of 0. The square root of 0 is of course just going to be 0. So we're going to add 0 and subtract 0 per that plus or minus there. And what that's going to do is actually produce the same solution twice. So whereas here, when we had a positive discriminant, we had 2 real solutions, we might say. Here, we have 1 repeated solution. Now, of course, in the negative case, what ends up happening is we're taking the square root of that negative number, right? If the discriminant is negative, we have to take the square root of that negative number. We don't know how to do that yet. We find out in level 3, but for now, we're just going to say that we have no real solutions. And that real part is critical because there are technically solutions, but they're just called complex or imaginary solutions, but aren't real. They don't really exist in the real world. Using this information, our good understanding of our achieved skill, we can move on to the next step of problem solving, which is having a good graphical explanation of what's going on here. So what is going on here? Well, if we have 2 real solutions, we hit the x-axis twice, as in there are 2 points where the equation y equals 0 and our equation y equals ax squared plus bx plus c meet. Right, so there are 2 points where they meet, so we might describe that as this curve here. It could also be a negative parabola, so we've got a positive parabola in this instance. If we have 1 repeated solution, it looks a little different. We actually are just barely kissing the x-axis effectively. So you could imagine we come in, and there's exactly 1 point that touches, draw that in red, and no other points. And so we have 1 repeated solution. And for no real solutions, well, we actually have no instances where this parabola touches the x-axis. We might describe it a little more like that, where it's floating above, or maybe it's a negative parabola floating below. Something like that, right? So that's our kind of visual understanding of what the discriminant is doing. So it's telling us how many solutions there are, or how many instances we are actually intersecting with the x-axis. So it doesn't mean the parabola is not real, it just means that we don't actually touch that x-axis. Okay, so now we've got our understanding of the achieved level skill and how that kind of looks graphically. Let's apply this to a question. So now hopefully you remember our third step is to take our knowledge and then put it into some kind of equation. And so I've got a question on the screen. It's an excellence question from the 2019 algebra paper. And I want you to have a go at it. So if you could read through it and maybe pause the video and see if you can get anything done, that would be really helpful to your learning. So hopefully you found that question okay. If you didn't, that's no worries. It is a little daunting, and it would be pretty scary in a paper to see that question C is actually an excellence question. But regardless, let's get started. So let's first define what a perfect square is. So a perfect square has a special characteristic where the discriminant equals 0. And so that's an important thing to memorize. You also might have an idea of a perfect square where we write it in the form y equals x minus a squared, for example. Those are really similar definitions. So if we recall correctly, the discriminant equals b squared minus 4ac, and we're saying that equals 0. All right. So what is b squared? Well, that's m plus 1 squared. M plus 1 squared. So that is our m plus 1 here. And then we have minus 4 times a, so a is the coefficient of x squared, which is 2m minus 1, and then we multiply that by m minus 4. And so now it's going to get a little bit algebraically heavy. We set this equal to 0, and now we're going to start expanding. So m squared plus 2m plus 1. Hopefully you understand why that expansion just happened then. If you don't, you've probably got some achieved skills to try and catch up on. Minus 4 times, now let's expand this inner bracket to 2m squared minus m minus 8m plus 4 equaling 0. And so if we expand this whole thing, m squared plus 2m plus 1 minus 8m squared plus 4m, and then plus 32m minus 16 equals 0. So we're going to get negative 7m squared. And then now we have to go 2 plus 4 plus 32 is 38. Then minus 15 equals 0. And we're just going to flip around the sign. So we're just going to divide everything by negative 1. We're allowed to do that. So 7m squared minus 38m plus 15 equals 0. That just makes it slightly easier to factorize. And so now what we're going to do is go 7m. You could do this in your calculator if you didn't know quite how to factorize this, but with a little bit of thought and experimentation about the factors of 15 and the 7 out front being prime, you can kind of arrive at the conclusion that we have 7m minus 3 m minus 5 equals 0, m equals 5, and 3 over 7. Cool. And we're nearly done. We just need to make one statement about whether or not these values are actually valid. And so if we think about the m minus 4 at the end, well, we would expect the constant of a perfect square to be at least 5. And the reason for that is that if we think about our graphical definition of a perfect square, where it's just kissing the x-axis here, we should expect that at no point is this positive parabola going to actually be negative. So we need this to be, m should be greater than 4, essentially, and that is because of this right here. And so we reject 3 over 7 and we say m equals 5. And we're done, and that's excellence in that question. And so that's how we go in level 2 from an achieved level skill to some kind of problem solving extrapolation, some kind of understanding, some better understanding of the discriminant, to actually getting excellence in this question. Cool, awesome. Let's move on to level 3. So now for level 3, we have to start with our achieved level skill. And that achieved level skill in level 3 calculus is going to be the chain rule. So it's really good to have the chain rule memorized. So if we write that out now, we should have the derivative that we're familiar with from level 2, dy by dx, equaling dy by du times du by dx. And if we're a little bit marginal and we treat derivatives like fractions, this kind of makes sense with the du cancelling the du on the bottom. Cool. So with that rule in mind, how do we apply it? Well, let's think about a relatively basic level 3 question. Maybe we have y equals 3x squared minus 4 to the power of 6. We need to differentiate this. What we're going to do first is identify what our u is. So our u is our inside function. So 3x squared minus 4, we might call u that. And that tells us that y equals u to the power of 6. So from here we can actually get du by dx, which is going to be, well, let's differentiate this, it's going to be 6x, and if we take this and differentiate this with respect to u, it's going to equal 6u to the power of 5. And so overall for dy by dx, we should get dy by du, which is 6u to the power of 5, times 6x, which is du by dx. Of course, our u doesn't really fit in very well. We may as well substitute it back into its form with x, so 6 times 3x squared minus 4 to the power of 5 times 6x. And that's going to be 36x times 3x squared minus 4 to the power of 5. And we're done with chain rule, right? That's our basic definition of chain rule. We have some kind of inside function where u is in terms of x and y is in terms of u, and we use this skill to solve achieved questions. So now let's move on to a more graphical understanding of the skill. And this is particularly important for our geometric questions that get given to us towards the end of the paper, the differentiation paper. So actually, with level 3, it's really helpful to have a full exam question to understand steps 2 and 3 out of the problem solving method, which is to firstly, or actually secondly, find some kind of graphical explanation of the rule that you're using. So we need to illustrate the question using diagrams. And after that, we need to try and put those diagrams back into the equations that are going to help us solve the problem. So I want you to have a read through this, see if you can answer the question. It's probably one of the more hard excellence questions in differentiation. A lot of students get stuck on it. But the interesting thing is that it only uses some kind of basic year 10 trigonometry as well as some achieved skills from year 13 differentiation. So have a go at this question and see if you can do it. All right, hopefully you paused the video, had a go, and are now back. Maybe you got a little stuck, maybe you'd like a more elegant solution. In this rectangle, we have a semicircle of radius r. And so we understand that this distance is r here, but the really critical thing is trying to understand where else r lies. So let's see what's relevant here. Show that the maximum possible area of such a rectangle occurs when x equals this. You do not need to prove that your solution gives the maximum area. So that tells us that we don't need the second derivative test. So what are we going to do here? We're going to find some kind of equation to represent the area of this rectangle, and then we are going to differentiate it. So firstly, in order to find the area of the rectangle, we need its width on the bottom. And it should be relatively clear that if we have x on one side and negative x on the other, we have a width of 2x. Now we need the height. Let's call this h for now because we don't know it. But that's really important, right? So it's going to, if we have the area, that's going to be 2x h. So in order to figure out h, we need to use a piece of sort of knowledge, which is that they've given us this r value, this radius, and it's a constant and it appears in the solution. So we can expect that we should use it in our solving of the question. And the way we're going to use it is through trigonometry. And this is really common with these level 3 differentiation questions that involve shapes. You need to just use Pythagoras' theorem, or the Pythagorean theorem rather. And so that's the idea that this is still r, right? So this length here is still r. And so we can express h in terms of r and x. We might say that we have a graphical interpretation here of just a triangle. We have x, and we have r, and we have h. And so we can just say that h equals x squared minus r squared, or the square root of that. And so what we're going to do is we're going to plug that into our area equation and say a equals, instead of 2xh, we're going to say 2x, the square root of x squared minus r squared. And now we don't actually have any other variable, right? Because r is a constant, we've got everything in terms of x, and that allows us to actually differentiate. And so dA by dx, what we're going to need to use both product rule and some kind of version of chain rule. So we're going to use we're going to have the derivative of the first function times the second, and then we're just going to add the first function times the derivative of the second function, which is going to be 2x times a half times 1 over x, the square root of x squared minus r squared. Cool. And we set that equal to 0. So all of a sudden, we have 2 root x minus x squared minus r squared equaling 2x squared over root x squared minus r squared. So yeah, it's just a wee algebraic jump to this. We're just moving this term to the other side. Okay, and now this is where a lot of students I see don't quite understand how to arrange this algebraically. It might be a good idea to go over a level 2 algebra paper before the level 3 calc test if you feel confident with some of these algebra skills. So one thing you can do here in order to simplify it is actually get this off the bottom. You'll notice that this is to the power of a half, this is to the power of negative a half. If we just multiply both sides by this square root function here, then we're going to get something much more clean. So we're going to get 2x squared minus r squared, x squared minus r squared, negative 2x squared, 2x squared minus r squared equals negative 2x squared. 4x squared equals 2r squared. X squared, 2x squared equals r squared. And then x squared equals r squared over 2. X equals square root of r squared over 2, which equals r over root 2. Should we have a plus or minus here? Well, that might be useful at first, but it's actually probably better just to keep the plus version, because of course r and x should have the same sign. Well, actually they're both going to be positive, right? Because they're both lengths. And so what we've done now is proved that that x equals r over root 2 at our maximum possible area. So what we did was understand the chain rule in our particular skill that we needed to utilize in differentiating this quite complex equation. We put one variable in terms of the other. We used algebra to manipulate h, our height, into being in terms of x, or x squared, and a constant. And we used a graphical interpretation of the question using this triangle here in order to actually do that. So using those 3 steps can help you solve problems in the level 3 differentiation exam, and particularly with those geometry problems. Best of luck. We haven't gone through every skill you need to learn in math, but what we have done is provided a framework. Firstly, go through past papers, understand what you found difficult. Secondly, master your ability not just to do, but to understand achieved level skills. And number 3, try to explain concepts both graphically or geometrically and algebraically. And finally, focus on reducing the amount of time you need to complete these questions. This allows you more time to go over concepts slower and not make mistakes in your exam. Best of luck for your NCEA exams, guys. You're gonna smash it, get excellence with these tips, and I'll see you later.